Hey there, future CCSP. I know you're out there getting ready for that exam. So
Yeah.
we're diving into something pretty important today, the core of cloud security cryptography.
It's a big one.
It is. We're going to be looking at trust models and PKI and hash functions.
Oh, and digital signatures.
Digital signatures, all that good stuff.
Okay.
It's really to help make those study sessions a little bit easier.
Yeah, make it stick.
Exactly.
Well.
So let's think about this like you're building this super secure cloud fortress, right?
Okay, I like that.
And we're giving you the tools to make sure only the right people get in.
The blueprints, the locks, the keys.
Exactly. And our listener who's working towards that CCSP certification, this is crucial for so many domains on the exam.
For sure.
So first things first, how do we even establish trust in the cloud?
Right, it's not like we can just hand over a physical key.
Right. It's all these intangible connections and data flying around.
Yeah, how do we know we're talking to the right person and nobody's listening in?
Exactly.
That's where these trust models come in.
Okay, so for the CCSP exam, this is all about security controls within the cloud data security domain.
Right.
So let's break down these trust models. What are the ways that we make sure that digital handshake is legitimate?
Well, one way is that old school in-person key exchange.
Right.
Like handing someone a physical key, but that doesn't really work in the digital world, does it?
Especially when we're talking about cloud services all over the globe.
No, not at all.
Not scalable.
So then you've got the web of trust model,
Yeah.
where it's a network of people basically vouching for each other,
Oh, interesting.
like a LinkedIn for digital signatures.
Okay.
You trust your connections and then they vouch for other people and it creates this chain.
So it works for smaller groups, but not really for big companies or cloud environments.
Right, it gets too complicated to manage.
Yeah, I can see that.
So the most common model today, the one that's really important for your exam, is the public key infrastructure.
Okay, PKI.
PKI, that's where these certificate authorities or CAs come in.
DEs. Okay.
They're like digital DMVs.
Okay.
They issue these digital certificates that verify who you are.
So those certificates are like our digital passports in the cloud.
Yeah, exactly.
They prove we are who we say we are.
Right.
So how does that actually work?
It's kind of like getting a driver's license. You go to the DMV with your documents.
Right.
They check them out and then they give you a license.
Yeah.
It's the same with digital certificates. You go to a CA with proof of your identity, they check it out and link it to your public key.
Okay.
And that creates your digital certificate. So it proves that your public key really belongs to you.
Makes sense now. What happens if someone gets a hold of my certificate? Do they have access to everything?
No, not at all. They could only use it to encrypt messages to you. They couldn't decrypt anything.
Okay.
Your private key is what unlocks everything. And as long as that stays safe, you're good.
Okay, good. So it's like they can send me a letter, but they can't actually open anything.
Exactly.
Okay, that's reassuring. So PKI is really at the heart of secure communication in the cloud then, right? It's for authentication data protection, even things like secure software updates.
It all comes back to PKI.
I can see why this is a big topic on the CCSP exam.
Yeah, foundational to building trust in the digital world.
Okay, so we've talked about making sure we're talking to the right people now. Let's talk about making sure that the data hasn't been messed with.
All right.
Let's talk about hash functions.
Like a digital fingerprint.
Ooh, I like that. A digital fingerprint.
So imagine you have a recipe for some amazing dish, right?
Okay.
Once you make the dish, you can't uncook it to get the recipe back.
Right. You can't reverse engineer it.
Exactly. That's what hash functions are. Like they're one-way streets. You put in any digital data, like a word or a whole database, and it spits out a unique hash.
A hash.
And that's a fixed length output.
So a text message, a massive server image, it all gets turned into this unique fingerprint.
Exactly.
And that fingerprint can tell us if anything's been changed.
Done to a single bit.
Wow. And that's because it's impossible for two different inputs to create the same hash.
Right? It's called collision resistance.
Collision resistance.
Like every snowflake is unique, every hash is unique.
Now, for someone studying for the CCSP exam, it's not just about knowing what a hash function is. It's about knowing the different types.
Yeah, because some are more secure than others.
Right. So let's talk about some of the big ones.
All right.
I know MD5 used to be really popular, but I hear it's not so secure anymore.
Yeah, MD5 is kind of like that lock that's been picked too many times.
So it's out.
It's out.
What about SHA-1?
SHA-1 is outdated, too vulnerable.
Okay, so those are the ones to avoid. What about SHA-2?
SHA-2 is still around, but because it's based on a similar structure to the older ones,
Oh, okay.
there are some worries about its long-term security.
So it's like building a house with the same blueprint as one that's known to have problems.
Exactly. You might be okay for now, but
It's always that risk.
always that risk.
So what's the gold standard then?
The one that's considered highly secure is SHA-3, also known as KCAC.
KCAC, okay.
It uses completely different math, so it's like building that secure house with a brand new blueprint.
Oh, okay, much better.
And we can't forget about RIPE-MD. It's another good one, famously used in Bitcoin.
Okay, so we've got these digital fingerprints, making sure the data is good. But how do we take it a step further? Like signing a contract in the digital world.
That's where digital signatures come in.
Okay.
They provide authenticity, integrity, and you can't deny signing it later.
Non-repudiation.
Non-repudiation, that's the word.
That's a mouthful.
It is. It's all based on those hash functions and asymmetric cryptography.
I'm starting to see how this all fits together. Can you break down how they work for our listener who might see this on the exam?
Sure. So let's say you want to send a signed document to someone.
Okay.
First, you create a hash of the document using one of those secure hash algorithms.
Okay.
Then you encrypt that hash using your private key, and that becomes your digital signature.
So it's like a super secure, tamper-proof seal tied to your identity because of that private key.
Exactly. Then you send the document and signature to your colleague. They calculate the hash on their end and decrypt your signature using your public key.
Okay.
If the two hashes match, it confirms you signed it, and the document hasn't been changed.
That's really clever.
It is. It's a really cool system.
Now, we've been talking about these digital certificates that are so important for PKI, but how are they made? And what happens when they expire or get compromised? I think our listener will want to know that.
Absolutely. Understanding the certificate life cycle is key for the CCSP exam.
Okay, so let's dive into that in part 2 of our deep dive.
Sounds good. Welcome back. So before we get into that certificate life cycle, I did want to touch on something we mentioned earlier, certificate revocation.
Oh, right.
For our listeners studying for the CCSP exam, knowing how to invalidate a certificate is really important when it's compromised or no longer needed.
Yeah, it's like that emergency shutoff if a key falls into the wrong hands.
Exactly. And we talked about those certificate revocation lists, like those wanted posters for bad certificates, but those can be kind of slow.
Yeah, not very efficient, like finding a needle in a haystack.
Right. So the more modern approach is the Online Certificate Status Protocol, or OCSP.
OCSP.
It's like a real-time checker. You know,
Yeah.
it instantly tells you if a certificate is still good.
Oh,
So whenever someone tries to use a certificate, their system pings the CEA to check its status.
much more efficient.
Much smoother and more secure.
Okay, that makes sense. So let's get into that certificate life cycle you mentioned.
Yeah.
I know our CCSP listeners are going to want to know this process.
Absolutely. So it all starts with generating a key pair, your public and private keys.
Okay.
Think of them like two halves of a secret code.
Okay.
One to lock or encrypt and one to unlock or decrypt.
Got it.
And then you create a certificate signing request, or a CSR.
CSR. Okay.
It's like filling out an application for your digital ID card.
So it's got your public key and your info, like your name and organization.
Exactly. And that all gets submitted to the certificate authority, the CA.
The CA, the gatekeeper.
That's them. They carefully check everything to make sure you are who you say you are.
That's a big responsibility. If they just give out certificates to anyone, the whole system falls apart.
Exactly. It would be chaos.
Okay, so once they've checked you out and confirmed your identity, what happens next?
They issue your certificate. And the important part is they digitally sign it with their own private key.
Okay, so it's like the official seal on a document.
Exactly. It's their stamp of approval, their way of vouching for you.
Okay.
And because their public key is widely trusted, anyone who gets your certificate can verify it.
By using the CA's public key to decrypt the signature.
Exactly. It's this really cool system of trust.
I'm seeing how these pieces fit together. The hash functions, the digital signatures, and the certificate authorities,
It's all connected.
all working together to build trust in the cloud. And for our listener who's studying for the CCSP, this is really key, right?
Absolutely. These concepts are the foundation for secure cloud operations.
Now, I want to go back to hash functions for a second. You said they're crucial for digital signatures. Can you explain how those unique fingerprints fit into the whole signing process?
Of course. So remember how a hash function creates that unique fingerprint for a message or file?
Yeah.
Well, when you sign something digitally, you're not actually signing the whole document.
You're not.
Nope, you're signing its hash.
Oh, so it's kind of like a shortcut, but just as secure?
Exactly. It's
Right.
more efficient, but just as valid.
So you hash the document,
Yeah.
then encrypt that hash with your private key,
Mm-hmm.
and that becomes your signature.
That's it.
So when someone gets a digitally signed document, they can verify it how?
First, they decrypt the signature using your public key to reveal the original hash.
Uh-huh.
Then they calculate the hash of the document themselves.
Using the same algorithm.
Right. And if the two hashes match,
It's confirmed.
authentic and hasn't been tampered with.
It's pretty amazing how it all works.
This is a really clever system.
Now, we've talked about how important trust is in the cloud, especially with all these digital exchanges happening all the time. Are there different types of trust models that are used?
Oh, yeah, definitely. And knowing that is really helpful for the CCSP exam.
Okay, so what are those models?
We'll get into those in part 3 of our deep dive.
Welcome back to the final part of our cryptography deep dive.
It's been quite a journey.
It really has. We've talked about certificates, hash functions, digital signatures.
The whole shebang.
Yeah. And now we're going to tackle those trust models.
Right.
I think this is where things get really interesting, especially for someone going for that CCSP certification.
You got it. Understanding trust models in the cloud is definitely important for that exam.
Okay, so what are the main models we need to know?
Let's focus on 3 key ones: hierarchical web of trust and bridge trust models.
Okay.
Each one has its own structure and applications.
Right.
Knowing their strengths and weaknesses is important for designing secure cloud solutions.
Okay, so let's start with the hierarchical model. Is that anything like those organizational charts we see in companies with different levels of authority?
You got it. It's a top-down structure. At the very top, you've got the root certificate authority. They're the big boss of trust.
Okay.
It issues certificates to intermediate CAs,
Okay.
and then they issue certificates to lower-level CAs and so on. It creates a chain of trust.
So it's like a pyramid with the root CA at the top holding the most power.
Yeah, exactly.
What does that mean for the system as a whole?
Well, it's efficient, and it's used a lot, but there's a risk if that root CA gets compromised.
Oh, wait.
The whole system could be in trouble.
Everything falls apart.
It's like a kingdom. If the king falls, the whole kingdom could be in turmoil.
Okay, so security for that root CA is super important.
Super important.
What about the web of trust model? We talked about that a bit earlier. It's more decentralized, right?
Exactly. There's no single root CA calling the shots.
Okay.
It's more like a network of people vouching for each other.
Based on their existing relationships.
Right, like that LinkedIn analogy.
Yeah.
You trust your connections and they trust others and so on.
Creates a web of trust.
A web of trust.
So what are the good and bad things about this model?
It's great for smaller communities or specific applications where you need that direct trust.
Okay.
But it doesn't work so well for big, complex environments like the cloud.
Yeah, too many moving parts.
It's hard to manage all those trust relationships when you have so many people involved.
Right, right. Now, what about this bridge trust model? It sounds like something you'd use when you have different groups or organizations.
That's a good observation. Bridge trust models are used to connect 2 separate hierarchical PKI systems.
Oh.
It's like building a bridge between 2 islands.
Okay.
Each island has its own internal trust structure.
So, for example, if 2 companies are working together and they need to share data, a bridge trust model would let them establish trust between their different PKI systems.
Exactly. A bridge CA acts as a trusted middleman.
Okay.
It allows certificates from one system to be validated in the other system.
So they can communicate securely.
Crucial for collaboration in today's world.
Okay. I'm really starting to see how these different trust models work together to address different security needs.
It's all about picking the right tool for the job.
This is so helpful for anyone prepping for the CCSP exam.
You bet. And remember, it's not just about memorizing definitions.
Right.
It's about understanding how these models are used in the real world and how they affect security decisions.
Absolutely. Well, we've covered so much in this deep dive.
Ground.
We've explored the basics of cryptography, the certificate lifecycle, and all these trust models. What are your final thoughts for our listeners, especially someone studying for that CCSP certification?
I'd say remember that cryptography is the foundation of cloud security.
The foundation.
It's not just theory, it's about actually using it.
Right.
So study these topics, carefully understand how they all connect, and think about how they apply to real-world problems.
Real-world challenges.
The CCSP exam will really test your ability to think critically and apply this knowledge.
Excellent advice. It's been awesome breaking down all this cryptography stuff with you.
It's been fun.
And to our listeners, keep those brains engaged and remember in the cloud trust, but verify. Until next time, happy learning.